that's it from me. So I might just open it to questions.
Gabriel from DIT SA. You don't have any examples to put into the wetland analysis tool at this stage, do you?
If you do want to use the wetland analysis tool, that's just another tab up here. So works very similarly to the music auditor. So these you'll probably leave them as is. You need the permanent pool volume for your wetland, so you can just get that from your model and put it in. And then you choose your file. Did that work? Yep. Okay, choose your file and upload it. And what it will do is it will go and calculate this inundation frequency curve. So there's a couple of things we look at for that. One is how much of the time is the wetland above a certain depth? So is it exceeding a certain depth more than 20% of the time? And what we do is we compare that with the plants, and essentially the idea is that if this depth is more than half the depth of your plants and you're exceeding that more than 20% of the time, that's probably enough to be starting to put your plants at risk. The second thing we look for is the 50th percentile, and we look to see whether the wetland is able to get itself back to normal water level or close to it for at least 50% of the time. This one's pretty good. It's pretty much there. In a wetland that's got problems, what we'll see is that this curve will be sitting, 100 or 200 mil above this normal water level for half the time, and that's telling you that basically it just can't drain out quickly enough. It's got too much water coming in, it can't drain itself quickly enough, and the real effective water level for the wetland's actually sitting well above what it's been designed to do. What that means is you essentially need to either modify the wetland, modify the outlet, modify the areas, or you need to rethink all of your planting and put all your plants further up the bank than what you'd planned initially, so that they've got depth ranges that are suitable for those particular types of plants. So go on, Gabriel.
As well, where it dries too quickly?
Sorry?
Do you have an example of the inverse of where the system dries too quickly?
Yeah, with the inverse, what you'll get is that this end of the tail will drop right off quickly, and you'll see it dropping out. It might be getting all the way down to the bottom at 80 or 90%, and then it'll flat line from there on. If you've got a system that's drying out completely, which I imagine in some of the drier parts of South Australia is very possible. So you'll see this dropping off sharply because of the evapotranspiration, and then it'll flat line at the bottom of the permanent pool, essentially. So the other part of this is that you can do a spells analysis. So you could, for example, if you're worried about that drying, you could say do a check and say, tell me how often is this less than -0.2 or something like that. And it will plot and it'll tell you how many times the water level goes below -0.2 and what the duration of that. So in this case, we've got 25 days that it's gone below the -0.2. And then you'd ask yourself, is that dry enough for long enough that it's putting our plants at risk? Is that a problem? So you could use that as a bit of an assessment to get an idea whether your system's getting too dry and for too long. And this doesn't tell you how long that period is. If it did that 50 times for one day, you probably wouldn't care. But if it's 25 days in one hit, that might be enough to be an issue. This is a second level of analysis, but one that I think we're not trying to introduce right now. But I think probably in the next few months or the next year or so, we'll try and add this on as another layer of information and detail you can do for your wetlands. And we're also working on a similar one for bioretention for soil moisture as well.